In the vast expanse of technological advancement, a new star is emerging: quantum computing. This field, once the stuff of science fiction, is now becoming a reality, promising to revolutionize the way we process information and solve complex problems. Quantum computing is not just an incremental improvement over classical computing, it represents a fundamental shift in our approach to computation. Rigetti Computing, a company at the forefront of this revolution, is captivating investors and scientists alike. Founded in 2013 by Chad Rigetti, the company has quickly established itself as a leader in the quantum computing space. Their mission is to build the world's most powerful computers to solve humanity's most pressing problems. Their stock performance, especially in comparison to giants like NVIDIA, hints at a seismic shift in the computing landscape. Investors are taking notice, and the financial markets are beginning to reflect the potential of quantum computing. Rigetti's growth is not just a flash in the pan, it is a sign of things to come. But what exactly is Rigetti, and why is it generating such excitement? To understand this, we need to delve into the world of quantum mechanics and the unique properties that make quantum computers so powerful. Rigetti is not just another computer company, they are pioneers, venturing into the uncharted territory of quantum mechanics to build machines that defy our current understanding of computation. Their approach combines cutting-edge hardware with sophisticated software to create a new kind of computer that can solve problems beyond the reach of classical machines. They are pioneers, venturing into the uncharted territory of quantum mechanics to build machines that defy our current understanding of computation. Quantum computers use qubits, which can exist in multiple states simultaneously, thanks to the principles of superposition and entanglement. This allows them to perform many calculations at once, making them exponentially more powerful than classical computers for certain tasks. Imagine a computer that doesn't rely on ones and zeros, but instead harnesses the bizarre laws of the quantum world. This is the promise of Rigetti, and it's a promise that has the potential to reshape our technological future. Quantum computers could revolutionize fields such as cryptography, optimization, and machine learning, opening up new possibilities that were previously unimaginable. This is the promise of Rigetti, and it's a promise that has the potential to reshape our technological future. The journey from classical to quantum computing is akin to the leap from the abacus to the modern computer. Each step forward brings us closer to unlocking new levels of computational power and efficiency. While NVIDIA excels in the realm of classical computing, powering everything from gaming PCs to artificial intelligence, Rigetti is playing a different game altogether. They are not just improving existing technology, they are creating an entirely new paradigm. This paradigm shift is not just about speed, it's about solving problems that were previously thought to be unsolvable. They are building the tools that will allow us to tackle problems that are impossible for even the most powerful classical computers to solve. This includes optimization problems in logistics, financial modeling, and even climate change simulations. The potential applications of quantum computing are vast and varied, and Rigetti is at the forefront of this exciting frontier. This includes designing life-saving drugs, revolutionizing materials science, and unlocking the secrets of the universe itself. Quantum computers can simulate molecular interactions at an unprecedented level of detail, leading to breakthroughs in drug discovery and materials engineering. This could lead to new treatments for diseases, stronger and lighter materials, and a deeper understanding of the fundamental forces that govern our world, and unlocking the secrets of the universe itself. Quantum computing could help us understand the nature of dark matter, the behavior of subatomic particles, and the origins of the universe. The possibilities are as vast as the universe itself, and Rigetti is leading the charge into this new frontier. The future is quantum, and Rigetti is leading the charge. As we stand on the brink of this new era, the work being done by Rigetti and other pioneers in the field will shape the technological landscape for generations to come. The promise of quantum computing is not just a distant dream, it is becoming a reality, and Rigetti is at the forefront of this exciting journey. The future is bright, and it is quantum. To understand the excitement surrounding Rigetti, we must first journey into the strange and counterintuitive world of quantum mechanics. This is a realm that defies our everyday experiences and challenges our understanding of reality itself. Quantum mechanics is not just a branch of physics, it is a fundamental framework that underpins the very fabric of the universe. It describes the behavior of particles at the smallest scales, where the classical laws of physics no longer apply. This is the realm of atoms and photons, where the rules of classical physics break down, and a new set of laws govern reality. In this microscopic world, particles behave in ways that seem bizarre and counterintuitive. They can be in multiple places at once, communicate instantaneously across vast distances, and exist in states that are both definite and indefinite at the same time. These phenomena are not just theoretical curiosities. They have profound implications for how we understand and interact with the world. In this quantum realm, particles can exist in multiple states at once, a phenomenon known as superposition. Superposition is one of the key principles that make quantum mechanics so powerful and so perplexing. It allows particles to be in a combination of states, rather than being confined to a single state. This means that a quantum particle, such as an electron, can be in multiple positions, have multiple energies, or even spin in multiple directions simultaneously. It's like a coin spinning in the air, being both heads and tails simultaneously until the moment it lands. This analogy helps to illustrate the concept of superposition, but the reality is even more complex. In the quantum world, particles do not simply flip between states. They exist in a superposition of all possible states until they are measured. This is what gives quantum systems their unique and powerful properties. Traditional computers, the ones we use every day, rely on bits, which can be either a 0 or a 1. These bits are the fundamental units of information in classical computing. They are like tiny switches that can be either on or off, representing binary states. Classical computers process information by manipulating these bits through a series of logical operations. This approach has been incredibly successful, powering everything from smartphones to supercomputers. Quantum computers, on the other hand, utilize qubits. Qubits are the quantum analogs of classical bits, but they are far more versatile. Unlike classical bits, which can only be in one of two states, qubits can exist in a superposition of states. This means that a single qubit can represent both 0 and 1 simultaneously, vastly increasing the computational power of quantum systems. Qubits, through the magic of superposition, can be both 0 and 1 at the same time. This ability to exist in multiple states is what gives quantum computers their extraordinary potential. By leveraging superposition, quantum computers can perform many calculations simultaneously rather than sequentially. This parallelism allows them to solve complex problems much more efficiently than classical computers. This fundamental difference is what gives quantum computers their immense power, but superposition is only one part of the story. Quantum computers also exploit another quantum phenomenon known as entanglement. When particles become entangled, their states become linked in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. This interconnectedness allows quantum computers to perform coordinated operations on multiple qubits simultaneously, further enhancing their computational capabilities. Imagine trying to navigate a maze with a classical computer. It would have to try each path one at a time until it found the exit. This process can be time-consuming and computationally expensive, especially for large and complex mazes. Classical computers are limited by their sequential processing, which means they can only explore one possibility at a time. It would have to try each path one at a time until it found the exit. This trial-and-error approach is characteristic of classical computing, where each possible solution must be evaluated individually. For many problems, this method is sufficient, but for others, it becomes impractical due to the sheer number of possibilities that need to be explored. A quantum computer, however, could explore all paths simultaneously, finding the solution exponentially faster. This is because quantum computers can leverage superposition and entanglement to process multiple possibilities at once. In the context of the maze, a quantum computer would not need to test each path individually. It could evaluate all paths in parallel, dramatically reducing the time required to find the exit. This ability to perform computations in parallel is what sets quantum computing apart. It allows quantum computers to tackle problems that are currently intractable for classical computers. For example, quantum computers have the potential to revolutionize fields such as cryptography, optimization, and drug discovery by solving problems that would take classical computers millions or even billions of years to solve. It's like having a million computers working in unison, tackling problems that would take classical computers billions of years to solve. This collective power is what makes quantum computing so exciting and so promising. By harnessing the principles of quantum mechanics, we can unlock new levels of computational efficiency and solve problems that were previously thought to be unsolvable. This opens up a universe of possibilities in fields like medicine, material science, and artificial intelligence. In medicine, quantum computers could be used to model complex biological systems, leading to new treatments and therapies. In materials science, they could help design new materials with unprecedented properties. In artificial intelligence, quantum computers could enable more powerful algorithms and faster training of machine learning models, making Rigetti's work all the more significant. Rigetti Computing is at the forefront of this quantum revolution, developing cutting-edge quantum hardware and software. Their work is paving the way for practical quantum applications that could transform industries and improve our understanding of the universe. The quantum revolution is upon us, and it promises to be just as transformative as the digital revolution that came before it. Just as the digital revolution brought about the internet, smartphones, and countless other innovations, the quantum revolution has the potential to reshape our world in ways we can only begin to imagine. It is an exciting time to be alive as we stand on the brink of a new era of technological